Okay, now the next device is the venturimeter. A venturimeter is usually inserted directly into the pipeline. So this is the figure of the venturimeter. Okay, so you have a larger uh, diameter pipe, then eventually magiging maliit siya. Magkakaroon ng tinatawag nating throat dito sa point 2. Okay? Now, a manometer is connected, or other devices is connected to the two pressure taps shown and measure the pressure difference at point 1 and point 2. So, this is your point 1 and point 2, and ito yung mga pressure taps. Okay? Now, the average velocity at point 1 is v sub 1 meters per second, while at point 2 is v sub 2 meters per second. Now, the difference is yung diameter sa point 1 is diameter 1. Of course, sa diameter 2, mas maliit siya. It's because of the throat. So, meron siyang throat. Okay? Now, for us to be able to obtain the formula for a venturimeter, we're gonna have to use again the Bernoulli's equation. So, for venturimeter, okay, using the formula delta P over density plus delta V squared all over 2G sub C plus, sorry, plus delta CG over G sub C plus the summation of all the friction losses plus the shaft work is equivalent to 0. Okay, again for venturimeter, so ito pa rin yung system natin. Then you have your pressure taps. Okay, so as you can see, ito yung system natin. Mas maliit siya. So therefore, we can assume that yung friction losses is equated to 0. Walang pump. So shaft torque is equivalent to 0. And there's no elevation. So therefore, this will become 0 also. Okay. Now, leaving us with a formula delta P over density plus delta V squared all over 2G sub C is equivalent to 0. Siyempre, mawala yung G sub C kapag ka SI. Also, since ito ay flow, so meron kang Q sub 1 at saka Q sub 2. Ang assumption dito, equivalent sila. So, therefore, we have A sub 1 V sub 1 is equivalent to A sub 2 V sub 2. Tama ba? Okay. Then, you have B sub 1 multiplied by pi D sub 1 squared all over 4 is equivalent to B sub 2 pi D sub 2 squared all over 4. Now, as you can see, parehong may pi over 4, so pwede natin i-cancel yun. Okay? Then, your equation will become B sub 1 D sub 1 squared is equivalent to V sub 2 T sub 2 squared. Or, simply, B sub 1 is equivalent to V sub 2 times D sub 2 all over D sub 1 quantity squared. Okay, so this is equation number 1. Now, pwede din tayo makakuha ng V sub 1 from this particular equation. Okay? SI unit tayo, so you have delta P over density plus v sub 2 squared over 2 minus v sub 1 squared over 2 is equivalent to 0. Okay, then we're gonna have transposing v sub 1 into the other side para maging positive. We have v sub 1 squared over 2 is equivalent to delta p over density plus p sub 2 squared over 2. Then, you multiply 2 sa lahat, no? Then, you're gonna have p sub 1 squared is equivalent to 2 delta p over density plus b sub 2 quantity squared. So, para pwede nating equate ito with the other one, i-square natin both side. We're gonna have v sub 1 squared is equivalent to b sub 2 squared quantity t sub 2 all over d sub 1 quantity raised to the 4th power. This one. Okay. Then, pwede natin equate kasi pareho silang b sub 1 squared. Okay, then your v sub 2 squared times d sub 2 all over d sub 1 quantity raised to the 4th power is equivalent to 2 delta p over density plus b sub 2 quantity squared. Okay, then pwedeng ito pwede natin i-transpose or pwede rin ito i-transpose natin sa kabila. Or pwede i-transpose lang natin itong term na to sa kabila. This will become 2 times p sub 1 minus p sub 2 over density is equivalent to v sub 2 squared minus v sub 2 squared times d sub 2 all over d sub 1 quantity raised to the 4th power. Okay, factor out natin yung b sub 2 squared. You have b sub 2 squared quantity 1 minus quantity d sub 2 all over d sub 1 quantity raised to the 4th power is equivalent to 2 p1 minus p2 all over the density. Then we obtain the value for v sub 2. This is then, or v sub 2 squared, this is equivalent to 2 quantity p1 minus p sub 2 over density divided by 1 minus a quantity d sub 2 over d sub 1 quantity raised to the 4th power. Then, your v sub 2 is equivalent to the square root of 2 quantity p1 minus p2 divided by the density all over 1 minus d sub 2 all over d sub 1 quantity raised to the 4th power quantity. This is your v sub 2, or the velocity measured using a venturimeter, which is actually equivalent to this particular equation. Yan. Well, they're the same. But, of course, we're gonna have to put the value for C sub B, or the coefficient for the venturimeter. Okay? Now, for many meters and a Reynolds number greater than 10 raised to the fourth power at point 1, C sub P is about 0.98 for pipe diameter below 0.2 meters and 0.99 for larger sizes. Okay, that's for C sub B. However, these coefficients can vary and individual calibration is recommended if the manufacturer's calibration is not available. Okay? Now, if you want to calculate for the flow rate or the volumetric flow rate, all we need to do is to calculate for the V sub 2 using this particular equation, and then you multiply it with the area, okay, of the pipe. So, since B sub 2 yan, so kailangan mo ng D sub 2, yung sa throat. Okay? Now, if for example, compressible gases yan, so for the measurement of compressible flow of gases, the adiabatic expansion from P sub 1 to P sub 2 pressure must be allowed for this particular equation. Okay? Now, a similar equation and the same coefficient C sub B are used along with the dimensionless expansion correction factor Y. So, if compressible gases, you may use this equation, but you're gonna have to calculate for the value of your Y. So, yung Y dito makukuha. Yan. First, alamin nyo yung pressure ratio at saka yung diameter ratio. Okay? Once you have the pressure ratio and the diameter ratio, then, i-project nyo, then makukuha nyo yung value ng Y, then yun yung gagamitin nyo dito sa equation na to. Okay? So, let us solve this particular problem. Now, a venturimeter having a throat diameter. So, problem. Venturimeter. So, throat diameter, sorry. Throat diameter is equivalent to 38.9 millimeter. Is installed in a line having an inside diameter, okay, inside is equivalent to 102.3 millimeter. So, this is your D sub 2 and this is your D sub 1. It meters water having a density. So, the density of water is equivalent to 999 kilograms per cubic meter. The measured pressure drop across the venturi, so delta P is equivalent to 156.9 kPa, kilopascal. We're also given the value of the coefficient of venturimeter, which is 0.98. We're being asked to calculate for, so we are required to calculate for the volumetric flow rate. So the volumetric flow rate in cubic meter per second. Okay. So solution, of course, using our formula. So ang nagpo-flow is water. So we're gonna have to use this equation. So we have this particular value. And then meron tayong kukuhang d sub 2 over d sub 1. Tapos, meron din tayong pressure drop, which is 156.9 kilo values inside. Then, your V sub 2 is equivalent to around 0.0208 meter cube per second. Sorry. This is still meter per seconds pa lang pala. Okay. Using the formula V sub 2 is equivalent to C sub V over square root of 1 minus d sub 2 over d sub 1 raised to the fourth power multiplied by the square root of 2 times p sub 1 minus p sub 2 divided by its density. So, makakapit kayo ng b sub 2, then you multiply it with the area. Okay? So, calculate your volumetric flow rate. You have v sub 2 times pi d sub 2 squared all over 4. The answer is equivalent to 0.0208 cubic meter per seconds. Paki-check na lang guys.